In the following lecture, Professor Raphael Markellos, IIBG Distinguished Professor at the Norwich Business School at the University of East Anglia in the UK, goes on a quest for wisdom in financial markets. Professor Markellos surveys some past empirical approaches and models for understanding market behavior, then explores some cutting-edge ways of taking into account investor sentiment and commitments to business responsibility.
The title, as mentioned, is The Quest for Wisdom in Financial Markets, which is a fancy, really, title for me to describe and discuss what I've been doing over the past couple of decades in terms of research. And over the next few slides, I'll try to tell you my story as a researcher, so my research journey, so where I started and what I did and how I did it and perhaps why I did it, and what I'm doing now in terms of research, and a few things about the future, so what I think is perhaps going to happen. So I've got three sections which I'm going to talk about, and you've also got the slides. So you've got all slides except one, the last one, which it's a secret and I'll keep it till the end. And I'll tell you what that is. So let's start. So this was the original motivation. So as a kid in the 80s, I got my first computer. This is a ZX Spectrum produced by Sir Sinclair. I think I got it for about £50. And this started a love affair, if you want to, with computing and programming and analyzing data and so on. Funnily enough, my computer tutor at the time, was using this to predict the outcome of football matches. So I was quite interested in that as I was seeing him, because he would collect data, what we would call fundamental data, about the performance of players or teams, and historical data, and he would use that in his computer, very much like this one, in order to predict what will happen in each football match. And he would use this in betting, in his own football betting. When I went to university, I continued using the likes of programming and computing, but I came across now econometrics, statistics, and the analysis of prices. So here you've got a stock market index, so prices in the stock market. So this is an index, and you can see its evolution. I think this is the S&P 500 from the 1950s up to 2008. Here you have price levels, and here you have what we call returns, so the changes in prices. And I was fascinated the first moment I saw this. The big challenge was that if you understood, if you found a way to predict what's going to happen in each one of these observations at each one of these times, this was the holy grail. You can become a billionaire. And it seemed very easy to do. I mean, looking at the graph, it just goes up and down. I mean, it must be some simple way, and I've got this powerful computer, or I can find others, where I will find this rule which will allow me to beat the market and to become very wealthy or very successful. So this was quite an interesting challenge. Funnily enough, I'm always quite interested in time series, not so much cross-sectional data. Funnily enough, this idea of time and dynamic models is something that I'm quite attracted. Now, I studied a bit more in finance and economics. I studied about the ideas of markets. As I told you, I was very optimistic in the beginning. So I had computers, I had data. I had read quite a lot in physics and mathematics, because that was one of my favorite subjects. And I came across a notion produced by a famous mathematician called Laplace. And he talked about a higher intellect, a demon. Sometimes this is translated as a Superman. And Laplace's demon is this fantastic imaginary machine, which he had in mind, or being, which if this intelligent being knew all the initial conditions, so he knew all the variables of everything in the universe, then through analysis, this is what he thought about hundreds of years ago, he could put all this in a single formula, a single mathematical formula, and on the basis of that, he could predict the movements or activity of anything in the universe. So Laplace was a mathematician. This was the notion of determinism. So if you know the initial conditions of a system and you've got the mathematical formula, you can predict anything in the future. And this is what I believed also in the stock market. So I've just got to discover this formula. I've just got to measure the conditions, the key variables. I'll feed them in a computer, and I'm going to see in the future. I hadn't read all the the developments in physics. Obviously, this was refuted later in thermodynamics, so all physical systems are not reversible. You have quantum mechanics also where there is uncertainty. You have chaotic systems and others. So we know now that this is not true. But in my young mind, I thought it was. So it's interesting that this notion of Laplace's demon continues to inspire people even now. So I was looking on the web, and there's actually a TV series that was produced last year in Japan called Rampo Kitan, Game of Laplace. And this is inspired and goes around this idea of Laplace's demon. So you can look it up. So it's nice that it's still an interesting thing. So in search of this demon, so what did I do after that? So I graduated, started my PhD research, and what I did yesterday evening was I was trying to summarize all my papers. There are about 40 of them. What I did is I created a word cloud with the titles of all my papers. Okay? So this is the word cloud. So the universe, if you want, of my research, the world of my research. Words that appear more frequently are larger in the graph, and words that are less frequent are less large. Now you can see from that there's some keywords that stand out. So for example, European. So I've done a lot of my research on European data. Most of it is equity markets, hence you have stock. Volatility is something that's central to my research. So I've looked at it for a number of years, and I'll tell you about that. Greek, so I've looked a lot at the Greek market, but also at others. Modeling, estimation, Garch. You'll see betting somewhere in there, football. So I've done some research on that. So this is what I'm going to tell you about. So bits and pieces around this research that I produced. So let's start looking at some specific projects, some specific issues that I looked. In the beginning, one of the things that interest me a lot, and I'm still working on, is this idea of nonlinearity. This was very popular in the 90s. So in the 90s, in the late 80s, there was a team or a direction in research which included physicists, mathematicians, what are called dynamic scientists, artificial intelligence researchers, computer scientists. And all these people were very inspired by a new wave of mathematics that became available, along with computer power. And they thought that these new models, these new nonlinear models, would be able to solve problems in a whole variety of disciplines. So they would create a new truth, not only in chemistry and physics and the sciences, but also in the social sciences. And they will allow us to model things better. So the standard model in finance, okay, what is the orthodox model, under the market, what is called the market efficiency, is that markets are unpredictable. And up to that point, this was well accepted. There was a lot of evidence that you cannot really predict markets using simple linear models. Now, we came along, I was part of, let's say, this movement, and we thought that perhaps the apparent unpredictability of markets is due to the fact that you're using the wrong models. So if you use perhaps nonlinear models, which are more sophisticated and haven't been tested in the past, you will be able to predict. So we looked at a variety of different models, but also nonlinear theories and also nonlinear tests in order to uncover these patterns that perhaps were hidden. And here I've got an example of what very simply is a nonlinear function, so this curve, and this linear function. So what would be physically, or if you want to optically, what this would look at. Now there's some concepts which are related to this, let's say, nonlinear literature. The idea, for example, of long memory. Some of these models, they allowed an impact of what happens today to have an impact not only tomorrow or next week, but an impact that lasts for years. So this idea of long memory that was first proposed by or made popular by a famous mathematician called Benoit Mandelbrot. The other one is jumps and discontinuities. So in linear models and in general in a lot of physical systems, you don't have sudden movements. Everything moves quite smoothly. Marshall, a famous economist, put this down and said that natura non facit saltum. Nature doesn't like jumps, likes to move gradually. But now we know in finance and a lot of social systems that you often have discontinuities, sudden jumps. In the stock market, you have crashes, or you have sudden flash movements and things. So these nonlinear models actually could produce this, and this is quite good because the linear ones couldn't. And finally, non-normal distributions. The standard model in finance, under various assumptions, is that returns are well behaved and follow this bell curve. For quite a number of years, we know this is not a particularly good approximation at high levels, and this has implications for risk management, but for pricing and a variety of other things. So these are the basic things that we looked about. Because I told you also about theories, one of the very popular theories at the time, which stems from maths, is the idea of chaos theory in the 90s. So the idea of chaos theory is that you have systems that are quite simple, okay? They're not very complicated, as we may have thought at that time. But because they have a specific nonlinear structure, they are unpredictable. And they are sensitive to initial conditions, and they have various characteristics. So look, where did this all lead? So this is it was beautiful research. It was interdisciplinary. We were all very, very optimistic about what was happening. So this is a picture of a fractal. So it is a very famous picture, which we will see it in a whole variety of places nowadays. This was again proposed, the father of fractals, Benoit Mandelbrot, this mathematician. And although this is a very complex picture, it is produced by an extremely simple formula. You can write it in half a sentence. It is extremely simple, this formula. But it can produce all this richness, which appears to be random. It is not random, although it does appear random. It has a very clear structure. It has some properties which are self-similarity. So if you magnify further and further down in this picture, you'll find an infinite amount of patterns which are similar to these, not exactly the same. Now, the graphical depiction has a physical depiction in chemistry, but it has a correspondence also in financial markets. So we thought, and this was our theoretical background, that perhaps markets operate in a similar manner. So there's structure, but it's hidden behind this nonlinearity. A famous model that was used quite a lot is called the logistic map. And this is just a simulation of this model. And this looks a bit random. It could be a stock return, one would say. But this, again, is produced by a very simple mathematical formula. And it is fully deterministic. There's no noise in here. There's no randomness. This is it's a mathematical model. It's not a statistical model. And it is unpredictable. You cannot predict it in the long term because it has this sensitive dependence on initial conditions. So all this was very nice, and we were very excited at the time. The practical applications of this and the next step wasn't that good. Unfortunately, these models didn't work in practice. We couldn't explain markets. Chaos existed under very specific conditions that weren't really relevant to financial markets. They were very noisy. In financial markets or in social systems, we have huge amounts of noise, which makes us quite different than physical systems, experiments in chemistry, for example. So I'm afraid to say, although this was very exciting research, it didn't really lead to many fruitful results in finance or in economics. But I think the use was, and Clive Granger says things and others, is that it opened our eyes. So until then, we looked at very simple models, and we were quite constrained in economics or in finance looking at a specific methodology. This opened our eyes to the whole variety of different approaches and methods and tools from physics and different ideas. I think it had a very positive impact on finance. So is nonlinearity useful? So here I've got some returns, and this is what we call the autocorrelation function of returns. So if this has large spikes, it means that you can predict something. And as you can see there, it's pretty noisy, it's pretty all over the place. And this is typical of data in finance. You cannot predict them using linear models. The same holds actually for nonlinear models. If you use a nonlinear model, it's very difficult to predict what's going on in finance. There's something different, though, if you look at another aspect of prices. And this is what we call volatility or variability in prices. And that turns out to be quite predictable. So there's a model which is extremely famous, and this became popular in the 90s. You might have heard of it. So this is called the Garch model, the generalized autoregressive conditionally heteroscedastic model. And this was proposed by somebody who got a Nobel Prize, Rob Engel, with Clive Granger. He proposed it in 1981 to model inflation. And this became extremely popular in finance. It's the workhorse of finance today. So when we want to model volatility, one of the simplest ways of doing it to model historical volatility is this Garch model. And this is a prediction from this model. And this is what remains after you've captured this structure. It's an extremely popular model. Now, the other development which is related to volatility, as I told you, I've done quite a lot of research in this area, was what is called the secularization of volatility, or volatility as a commodity. So at some point, somebody thought, if volatility is so important, and it is, because it's behind most financial decisions. So in cost of capital, in MPV, in measuring risk, in portfolio theory, volatility is everywhere. The reason why it is everywhere in finance it's because it is a measure of risk. It's a measure of aggregate risk. So, and as you know, everything in finance is driven by risk. This is what drives expected returns. So if you want to model that, that's how it happens. So somebody in the States thought, why don't we create a commodity? Why don't we create something that we can buy and sell? And they created the VIX index, so the volatility index in Chicago. And this has been a hugely successful story. So this is the VIX options and futures are one of the most heavily traded in the world. They have a huge amount of liquidity. They were very, very popular with investors because of the importance of the underlying variable. And they're also used very commonly in newspapers or by journalists as a measure of uncertainty and fear in markets. Sometimes they call it the fear index. Here, for example, you can see the VIX index over the past few years. And here you have the Lehman Brothers crisis. Here you've got the Greek sovereign debt crisis. And here you've got the Eurozone crisis and the US downgrade. You can see how the VIX kind of reflects all these things that are happening in the wider world. Something that is important to measure is that although this volatility is everywhere in finance, we don't observe it. It's not like prices where we know what it is. So we can only approximate volatility to some extent. We don't actually know exactly what it is. So we've got a whole variety of methods. The Garch model, which I mentioned, was one of them, in order to get a feeling what the volatility is. But we don't know exactly what it is. This is the problem. And some of my research was interested in this, trying to analyze this. So if we don't know what volatility is, and we're trying to approximate it, that means that we're making a mistake. There's an error in measuring volatility. And if we use this mistaken estimate in our financial decisions, what will be the impact? This is the question that I asked. And the initial application was in the CAPM model. Then we used it in option pricing. And we try to see what happens if you plug in this estimate in these models. It turns out that if your problem is nonlinear, like in option pricing, for example, the effect of this mistake is quite unpredictable. It's not necessarily marginal, the impact. So for example, in the Garch option pricing model, which is one of the, again, a quite widely used one, we study the uncertainty, the volatility, and how it affected option prices and hedge ratios of the Greeks. And that was an interesting setting. But what I'm going to show here, which is hopefully a bit more intuitive, is the application of error in measuring volatility, and we call this estimation risk, the impact on portfolio theory and asset allocation. So this is something that we often teach in business schools, and there's a guy called Harry Markovich, which is the father of quantitative finance. So in the 1950s, Harry Markovich came along and actually created quantitative finance. So until that point, finance was a collection of heuristics, rules of thumb, financial ratios. We weren't really sure what we were doing. He made it a science. So he came in the 1950s and proposed a method, and he said, I will tell you how you should allocate your money. So if you've got these 1,000 alternative investments, I will tell you exactly how much you should put in each one of these different investments. And the only information you need in order to take that decision is the return, the variance or volatility, and the covariance between these assets, and also your level of aversion to risk. If you know all these things, I will tell you exactly how much you have to put in each asset. Let's use an analogy with baskets and eggs. Okay? So the basket is an investment, a stock if you want to, and the eggs is the amount of money that you should put in each basket. In all cultures all around the world, there is a saying amongst very simple people that you shouldn't put all your eggs in one basket. This has different variations, but the essence is the same. So in China or in Greece or in Europe, all popular cultures have this idea that you should diversify your risk. You should spread it across different baskets. So Markovich proposed a mathematical way to solve this problem, and he told us exactly how much money we should put in each basket. And this is great. As I said, a key number in this decision is volatility, or its product, which is co-volatility or covariance. Now then something very dramatic happened in 2009. So there was a group of researchers led by Victor de Miguel, Lorenzo Garlapi and Raman Upal, and they published a study which changed the world of finance for me. This is one of the most widely studied papers over recent years. So they took the Markovitch model and they compared it with a very simple rule. So what if I take the n alternative investments that I have and just divide equally the money between them? No, don't optimize anything. Just use this passive, if you want to, or naive rule. We call this 1 divided by n. So I'm taking my money and dividing it by n alternative investments, and then I'm spreading it. So I've got an equal number of eggs in each basket. And the unexpected result out of this study was that the 1 over n rule was much better than the Markovitch approach. So all this effort for 50 and 60 years, all these models, all this quantitative analysis, all this computer power, could not beat the 1 over n rule. So this created a huge debate and uncertainty and pessimism, I would say, amongst the quantitative researchers. So what are we doing? All these years of research or work are wasted. Just spread your money across different assets. And for the past, let's say, 6 or 7 years, there's been quite a lot of research. We've also contributed to that debate of trying to fix Markovitch and try to find ways of improving it. And it's very difficult to beat the 1 over n. It is possible, but it is quite difficult. One of the reasons why this is better than this is that here you're not estimating anything. Here you're just dividing your money simply. There isn't any estimation. There isn't any estimation risk. Volatility, estimation risk, doesn't affect this. Whilst this method here depends critically on the accuracy of the parameters that you're using to solve the problem. If your parameters are uncertain and wrong, your solution will be wrong. One of the solutions that we've been working on for quite a long time with my colleague Apostolos Kourtis from Norwich Business School, so he's the head of the finance group there. So for about 10 years now, we're working on a new method which we think is very, very exciting and very good, where it has 2 steps. So rather than using all the baskets, we select only a limited number of baskets. So we choose the best baskets if you want to. And then we do portfolio optimization in this select number of baskets. Now this might not seem, it works in practice and it does a bit better than quite better than the 1 over n, but I would say the revolution in this method is that it has a completely different approach. What I told you, the dogma, if you want to, in finance, which we tell all our students in all textbooks, is you should always diversify. You should always spread your assets to as many possible investments. Something like 20 or 25 is the rule of thumb, but you should never concentrate your assets in a small number of stocks. We actually say exactly the opposite. So we say that because of estimation risk, the more your assets you're including in your portfolio, the more parameters you have to estimate, the more things can go wrong. So there's a trade-off between reducing unsystematic risk, which is what diversification does, and reducing estimation risk. And we've done various experiments and empirical work on this and simulations, and it turns out that in realistic settings, the optimal portfolio size is around 3 or 4 assets. And funnily enough, this is what a lot of investors actually hold. So a lot of investors actually hold a very limited number of assets. They don't hold 20 or 30. So this is very exciting research that we're working on now, and I think it will contribute to this debate quite a lot. So this was the first part of what I did, let's say, in the early part of my research. The second part, as I said, has to do with behavior, sentiment, cognition, and information, and how going, let's say, from the model of perfectly rational investors, there was a strand of literature, which again, I did some work in that, where behavior becomes important. We actually know about the importance of sentiment and behavior for hundreds of years. So this is a print by William Hogarth, more than 300 years ago, and this describes the chaotic and irrational situation which followed what is called the South Sea Bubble scheme. So this is one of the big financial crises that we know that happened in hundreds of years ago, about a expedition company that issued stocks, and these reached exuberant prices and so on. And it's interesting, we don't have time to go to an analysis. I knew somebody who did a dissertation on this. The irrational behaviors that are described in this fascinating print. So what do we know after all this research? So this is not a new idea. So technical analysts, if you've came across them, so these practitioners which tried to predict markets in the early days, around 1900, actually knew about this quite well. So they talked quite often about the effect of sentiment. They even talked about the effect of weather. So one of the famous hypotheses that we have in behavioral finance is the effect of weather on traders. So apparently when it's sunny, they feel more optimistic, and on average, this will affect the returns in the market. And this has been studied in many, many different markets, and we have some conclusive results. But this was actually described 100 years ago by them, so they knew about this. The foundations is really on Simon in bounded rationality in the 50s, and there's two researchers which are very important in this literature, two psychologists, so Kahneman and Tversky in the 1970s, and they studied a number of psychological biases. So we have, on the one hand side, we have the traditional efficient market, so everything is rational, everybody follows one way of thinking, and they calculate everything and make the right decisions. And on the other hand is that we are victim of our biases, and we are complex and diverse. And psychology and sentiment affects what we do to a larger or to a smaller extent, depending on what we will. So who's got the right answer? My favorite response to that question is that the Nobel Prize in 2013 was given to three people. One of them was Eugene Fama, who was the father of the efficient market hypothesis. And on the other hand, you had Rob Shiller, who was, let's say, did most of the work, the first seminal work in behavioral finance. So economists will actually give a Nobel Prize to two people that believe exactly the opposite things. This is a great thing about economics. So both are right to a smaller, larger extent, and we're trying to understand what's going on. So it's not black and white. So there are fades of grade, and we have to understand really what's going on. So both of them have segments of truth. What I always like to, I've got paraphrased here a famous verse from a poet, so Maya Angelou. So investors will forget what you said, or shareholders if you want to. They will forget what you did, but they will never forget how you made them feel. So this is applicable to a large number of situations. So people will all remember their feelings. So press releases or news or fundamentals will come and go, but if you make them feel bad, especially because it's asymmetric, they will remember that forever. This has applications also in politics, which are quite interesting, but also in business and finance. So the next area, so this is really what happened and what others did. So how did I contribute to this research? So at some point in my career, working with one of my colleagues, Nikos Vlastakis and others, we came across a betting data set. This was in early 2000. And I was quite fascinated. As I said, I had this, when I first working with computers, I had somebody who worked on betting. I was quite fascinated by how betting markets worked. And if you've looked in the literature, betting markets are considered a very good experiment lab to study financial markets. And the reason is because they're quite simple in their construction. You know the outcome, so somebody will win the match or not. So it's a defined output, which in finance it doesn't exist. You have very high quality data. You have a lot of market participants. You've got market makers. So you've got all the characteristics of a financial market if you want to, but in quite clear settings. So there's a number of studies that have been published in that area, and we contributed to that debate. We actually looked at football betting because that was the data set we had. And it confirmed really to a large extent what others have found is that betting markets are influenced by psychological biases. So the favorite long shot bias, for example, which is a famous bias which we've observed for many, many, many years. Consistently, although gamblers know about it, and this is all very famous, it still exists in the odds. So in the way that the bookies are pricing odds. This also happens in horse betting or in all different types of betting markets. So that gave us really an understanding of biases, how they work in a very specific setting, and that was very interesting, and made me more interested in this literature. So the next step that we did in this literature is that we did a few studies also on weather and the stock market, but something else that we came across and we quite liked is around 2005, Google started to produce some data which was related to the search intensity. So they started producing some time series. Initially there were graphs, they didn't give the data. So these were time series of how popular various keywords were through time. So what people were searching, search intensities in Google. And this is called now Google Trends. And it gives us trends of the popularity of various keywords. So what we did, and there was another research team in the US, what we did is that we looked at the popularity of various companies in Google. So how often people are searching for keywords related to specific companies. So the name of the company if you want to, or the Reuters acronyms, or the trading acronym. And we compared that to market activity in general. And what we found was quite interesting is that what people were searching on the internet seemed to be related to what's happening in the stock market. So this is the popularity of the search keyword related to the S&P 500. So how often people are searching S&P 500. And here in that graph you also have the volatility of the S&P 500. So how, as captured by the VIX index. And we found that these work quite closely together. Until that time, what had been studied was the supply of information. So what a lot of researchers did for about 20 years is that they took the number of Reuters stories related to a particular stock, or they took the number of headlines and they counted them in relation to a specific stock. So that was the supply of information. So what we did here for the first time is we looked at the demand for information, because through Google you're demanding, you're looking for information. It has to do with attention. So this demand and supply of information is something that we studied, and we found we were trying to look at things: what leads, so what's first, what follows, where does information discovery take place, and if this has some predictive value. So this was published in the Journal of Banking and Finance, and it was quite widely cited in this literature. There was another paper by Da in the US, which also looked at it from a slightly different perspective, from perspective of attention, and we still work quite well with this. Another interesting report or paper that we are working on now in this literature is this idea of macro sentiment. You might have seen a data set produced by Google in digitizing their books. So if you go online, Google has created in digital form, I think it's 5% or 10% of the total books that have been ever printed over the past hundreds of years. And they'll give the text online, and you can analyze that. So what we did is that so this particular sample is over the past 200 years, we analyzed the sentiment, okay, that is reflected in the text of these books, these millions of books, and we studied that through time. So most people study micro sentiment. So what they'll do is they look at newspapers in a particular year, or they look at online reviews. So we look at macro sentiment over hundreds of years to see what happens. And what we find is in this study is that it has a close correspondence to what's happening in the world, which isn't really a surprise. So here you have the Second World War, you have the revolution in the United States, you have the petrol crisis. So there are various large events and periods which are reflected in this sentiment. The question is, does this have predictive value? And in fact, it does. We correlate this, or we run some predictive models, and we try and use this macro sentiment in predicting what will happen in the market in the US, in the UK, in France, and in other countries, because these were published in different countries. And it turns out that this macro sentiment has predictive power. One more study which is related to this idea of sentiment is a study that we've recently completed with my PhD student Jessica Wang, who's at Nottingham Business School. And we played around with the idea of sports sentiment, which became quite popular after a paper published by Edmonds in Journal of Finance. And he looked at football and how the football results affected the stock market. And he tried to correlate the two. So we did something very similar, but instead of looking at football, we looked at Olympic Games. The reason being that Olympic Games are popular in a much larger number of countries. So football is quite specific, whilst the Olympic Games, you have a much wider sample. And the interesting thing is that for Olympic Games, these are related to a country, but also to companies, because you have sponsor companies. So for example, we studied Samsung and others that were related. And and the hypothesis was that the number of medals that a country wins will affect the stock market in that particular country. Now what we found is that returns are not affected. So if a country wins, if the US wins many medals on a particular day, the stock market in the near future is not affected. The hypothesis is that traders will become more optimistic. You have this idea of they will affect their decision making and their risk aversion. So this is the hypothesis in the Edmonds study. But what we do find, interestingly enough, is that on the next day, volatility is reduced and trading volume is reduced. And the hypothesis that we propose in the paper is that of distraction. So the sentiment of investors is not affected, at least from the Olympic Games. But what happens, as everybody in the Olympic Games, perhaps it's the same as in Hong Kong, I'm not sure, is that during the Olympic Games, when your team, the national team, is perhaps going to win a medal or it wins a lot of medals, everybody's at the TV. So the clients or the traders, they might be out socializing. So everybody's distracted by this. And we have quite a lot of evidence that TV viewing goes up during this period and so on. So rather than talking about this idea of sports sentiment, we propose this idea of sports distraction in this particular paper. And these two notions is something that has not been studied, I think, enough in the literature. We believe that a lot of the things that are related to sentiment might actually be more related to distraction. So another idea that I quite like, as an analogy with paintings and photography, is what I'm going to talk about in this slide. So I would say our original objective in finance, but also in economics, is to model things extremely realistically. Okay, so to have a model which is very complex and which depicts exactly what's going on in reality. And this is let's say, I would say the conventional objective in modeling. If you think about it, a painting or a photograph has a very similar objective. A painting, in particular a photograph, is a depiction of reality, what's going on. So a photograph, it's a model because it's not exactly realistic, so it's 2 dimensions. You don't have the other things that you have in a forest, for example. You don't have smell, you don't have sounds from the birds, so it is a model, it's an abstraction of reality. But it's supposed to be as realistic as possible, okay? And then it is considered successful. Now, what happened in art, for a variety of reasons compared to technology at the time, was that artists at some point decided that we will stop becoming realistic. So the Dutch masters, for example, if you see a painting by Dutch masters, it is exactly realistic. The colors on the birds and the fruit and so on, they're exactly, nearly like a photograph. They had reached a level of technique that was so good that it was almost like a photograph. But the artists after that point said that we will stop doing that. One of the reasons was that photographs could actually do it better, because technology at that time meant that photographs came out, and artists had to compete with photographers. But photographers, with just a click, could produce something that a painter may need weeks or months or years. So they had to come up with something else. So they said that instead of producing a painting, I'll produce perhaps the feeling that a particular scene leaves you, or the impression, the impressionists. They talked about the impression that something is leaving. Or they might talk about an idea that is behind a scene. So for example, if you want to literally, but I would say that our simplistic approach to modeling is that we're trying to very simply put a crude description of this forest. Something like this, if you want to, in this painting, in this Kandinsky painting. But I think that it would be much more interesting to see models as a much more complex depiction of reality. So we talked about sentiments. So if there's sentiment, there's subjectivity. So one specific model will not be able to describe reality. If what's happening on in markets is subjective because it depends on individual circumstances or behavior, then that means that you should model different behaviors. You should model the impression that it has on investors rather than a single universal impression that it has on everybody. So I think it's an interesting idea to think about models in this way, because so we have to seek richer models of reality. And this subjectivity, somehow we have to be able to model it. Perhaps artificial intelligence is the tool where it will allow us to have a much more rich representation of reality. So the future, going forward, so what I'm working on now and what I think might be useful for others. So I talked about this obsession with prices at the beginning, so time series and prices and so on. My current belief and work is around the idea that prices are not the only thing in the picture. In an efficient market, okay, in a perfect market, prices will reflect all the information, and they'll do that accurately, instantly, and correctly. So in a perfect market, the only thing that you need is prices. But if you don't have a perfect market, and in many circumstances we think that it is not absolutely perfect, then there'll be other information which will also count. And to give you an example, when we're analyzing a firm, we will look at the prices, we'll look at fundamental information related to financial ratios, accounting data, profit predictions, all these things, which may be a quarter old, or it might be a week or months old, and this is quite stale. I think there's a rich variety of data that is beyond prices that we should also look at. So for example, if we're talking about consumer goods, what about reviews that customers are making on Amazon? If we're talking about a hotel, what about the reviews that is going on TripAdvisor or Booking.com? What about the behavior of consumers with alternative products or with competitors? So there's a wealth of information out there that I think we should consider, and I actually think it has a lot of predictive value. Prices and accounting data are very useful, but it's a bit stale. Consumers and purchases and their intentions and their search activities on the internet is what is going to lead to purchases, and it's going to lead to profits and revenues, and after a few months it's going to lead to accounting data and prices in the stock market. So I think we have to take a step back and look at the broader picture. It's not only prices or numbers that we should be looking at, it could be text. So if we're looking at the reviews of consumers, which will create profits, perhaps we should analyze the text of the online reviews that they're making about products. So we could do sentiment analysis about these. So we're going to measure their emotions. There's also images. So there's a new approach in measuring sentiment which looks at the image and does image sentiment analysis, or even sound. And this general idea, I would put it under the rubric of business reality mining. So looking at a business and trying to mine the reality around consumers from every possible perspective, rather than narrowly looking only at numbers. And all this leads to the idea that, I think in the future, business disciplines and academic disciplines will become much, much closer. This is happening already in business, but not so much in academia. So we're still thinking in terms of narrow disciplines. I do finance, I do marketing, I do HR, and so on. It turns out that the data now, I think, is going to bring us all together. So for example, if I'm going to study the problem to try to figure out what a company is doing, I will look at HR data, so Glassdoor data about satisfaction. I'll look at consumer data. I'll look at what's it doing in terms of logistics. So there's a whole different of disciplines and data sources that I should consider. My guess or my forecast is that perhaps in 20 years, Bloomberg will not only include accounting data or financial data, it will include all this different data. This is happening to some extent already. So for example, you have social media feeds in Bloomberg or Reuters. So you have sentiment analysis and what people are talking about, which is already in the official system. So the last part is with this, going to this idea of wisdom and what's going to happen in general. And to kind of frame this discussion, I've picked one of my favorite paintings. So this is a fishing scene because it's a fishing village near Norwich, and fishing is quite a big industry. It was painted by John Cotman in 1831, and it's at Yarmouth. And it's interesting that you see a storm here, and this is really my point. And you see a bright side here on the left, and you see a quite dark and dramatic and perhaps pessimistic side on the left. And I would say the point that I'm going to lead to is climate change and the environment and how this affects us or economic activity. So at some point in my research, this was after 2000, climate change was starting to become a big thing. And I was also considering it and see how this will affect my research and what should I do in order to help. So in Europe, we had the carbon market, so the emission allowances, where this was traded as a financial market. And one of the first things we did is to try and find a way to price this new asset in a way that is fair using the tools that we had. So we did a study that was quite influential in this literature, that was published in the Journal of Banking and Finance, and it was extremely widely cited, which proposed for the first time a model in order to price options and futures in this new type of market. But I would say that was kind of a technical thing. and it wasn't really what I was looking at. So it perhaps helped a bit in this literature and this problem, but what bugged me really, and what is still bugging me, is how financial managers and how myself as a researcher, I can account for these environmental problems in my decisions. So I teach my students about maximization of shareholder wealth. I teach them about the constraints, so you'll have CSR, and you'll have society and employees, so it can't be completely unconstrained. But practically, there's not much there. So the managers don't have tools in order to incorporate the environment or other social objectives in their analysis. It's interesting here to draw an example, an inspiration that again comes from my home city. Perhaps a lot of you, or some of you, have come across this mustard. So this is Coleman's mustard, and it's the most famous English mustard. And it's been around for hundreds of years. It's a very successful brand. They produce other things except mustard. But the entrepreneur behind it is a very interesting person, and he's depicted in this picture. So he's Coleman. He's actually one of the many Colemans that created and run the factory, but the most well-known one. So this is Jeremiah James Coleman. And he was a fantastic businessman because he created this global brand, which was one of the top companies in the UK, but also globally for a number of years. But that's not why I'm mentioning him here. He was financially successful, but at the same time, he was perhaps the first person, and this is not very well known, who introduced the idea of respecting employees and also the environment and also the society around him. So 50 years before the creation of the welfare state in the UK, 20 years before compulsory education was introduced in the UK, so these were the Victorian times, Coleman created a nursery for his employees. He created a pension system for his employees. He created an insurance scheme for the employees. He had food provision, medical care, even recycling in his hospital. So he was this very big, very different than what other people were doing in his time. So the typical entrepreneur those times would use kids in production. They would exploit them. The pay would be very low, and there would be no provision whatsoever for the welfare of the employees. So, and this one would say that it would hurt his profits. But as it turned out, it didn't. So he created this fantastic brand. He was very successful, and he had employees. There were about 2,000 at the time that were very successful, and we still remember that. But the interesting thing for me is not what he did, but why he did it. So in his writings or in his discussions, he actually had this notion of ethics in driving his decision. So sometimes when I teach this as MBA classes, so why you should do CSR? So as financial managers, why should you sacrifice financial objectives for the environment or for doing good to the community and so on? And often students will come back and say, because it's good for our brand, because it's good, because you'll have more customers. If I do this, it will appear good for publicity, and more customers will buy my products. And I'm not happy with that notion. It's quite cynical. And Coleman was quite clear on this, and others that are like him, that he did it because it was ethically right. He didn't do it because there was some hidden financial objective. He did it because he was a very religious man. He believed that this is what you should do. This is ethical. This is the right thing to do. And this is, I think, a right inspiration in thinking about how going forward in finance and about this idea of wisdom. So I've got here a definition. I'll tell you a few things about it. So there's an idea which is proposed and is studied recently in the leadership literature, so in the management literature. And this is the idea of phronesis. And it was discussed in ancient Greek philosophers, Plato, but mainly Aristotle. And the translation would be in English, sometimes it's translated as practical wisdom. And what this is, so Aristotle looked at three types of behind our mindset and making decisions. So he talked about science, episteme, so if you want to, what academics do. He talks about technique, technology, and he called that technique. So actually implementing something, so the practical aspects, so technical education if you want to. But then the third component was practical wisdom, so this idea of phronesis. So what is phronesis? It's defined as the habit of making the right decisions and taking the right actions in context, and the relentless pursuit of excellence for common good. It reflects a learned ability to make judgments in accordance with the development of virtue and with the experience gained over time. A virtue with two components, an intellectual and a moral one. So intellect and morality are very closely related. part of a triad concept comprised, as I told you, of scientific knowledge and technical knowledge. Those of you that have read a bit, or I'm sure you have, in Eastern philosophy, especially Confucius, these ideas are very similar. And actually there are journal papers and conferences which are devoted on the similarities between Eastern and Western philosophy, and how the ideas of Confucius and others are similar to what Aristotle tells us here. There's a paper which is very relevant, so this is drawn out of a book of an old colleague of mine, Dimitris Bouradas, but there's a paper in the Harvard Business Review which is quite good, and you should, if you're interested, to have a look at. So it's about the big idea and the wise leader by Nonaka and Takeuchi, published in 2011. So again, if it is a bit I think it is a bit similar. So two central concepts in Confucian ethics, so the idea of Ren, humanity, and Li, sorry about the pronunciation, so propriety, benefit, and order, seem to be similar to these ideas in practical wisdom. So what I'm trying to say here is that in finance we've been obsessed for many years, and we're thinking about this idea of how to do things and what to do. And we're teaching our students, and we're doing research on that. So I'm always teaching my classes, as students, this is what you should do. This is the technique. Do the NPV, do the portfolio optimization. Okay. And we spend hours and hours in lectures in doing that. But we very, very rarely think about the why. So why should you do this? So why should you pursue this objective? Sometimes we tell them that this is what you should do. Okay, so we're quite pedantic as shareholder maximization. This is why. So why are we doing NPV? Because of shareholder maximization. Why are we doing this? Because that is the answer. But I think what leaders have to do, and what our students have to do, is think about why. What is the justification of doing that? And I think this will lead perhaps to better decisions rather than take them as something that is given. So I told you, I promised you the hidden fast slide. So how can we best predict the future? And so this is a long-standing ambition. So this is how I started. So how am I going to predict the future? And I had these models. I told you about Laplace and his demon, and that failed. Then talking about these paintings and if that can be useful and behavior and all that. So again, I'm going to draw from the ancient philosophers in finding the answer. So there's this philosopher which is called Heraclitus in 500 BC, so 2,500 years ago, and he was also interested in what happens in the universe. And he came up with this very good and short description. So ethos is fate. In another translation, character is your destiny. So he said that your character, so your ethos, it's actually the same word as ethics. So your ethics and what your beliefs are and so on will be your destiny. This is where you're going to go. So in the future, you're going to end up where your character will lead you. You can't leave that. I think this has an interesting application both to countries and to companies and to individuals. So it might not happen in the short term. So you might avoid your destiny on the basis of your moral decisions, but in the long term, this is where you're gonna end up. Interestingly enough, the ancient Greek, if you want to, original text is ethos, which is ethos, anthropo, which is human, and demon, so demon. So the idea of demon comes in again. So he said that your demon, what will guide, or what will be this intellect, what will guide your future, will be your ethics. So it turns out that I can't avoid this idea of a demon, but this is my short answer to how to predict the future. So your character, or the character of the companies, is going to define where they're going to go. So I think I'll leave it there. So thank you very much for your attention.